How many of you have posted letter last 1 year? Last 2 years? It's very good. The biggest problem with our tendencies are that if I don't post letter, nobody else posts letters in the world. Which is the problem of design, where we need to never put ourselves in the shoes of the user, thinking that because of the modern technology, because of very good mobile phones and cell phones and all, people are not going to post letters. So then we did a survey and found out a lot of people use letters today, and the volume of letters have increased multifold in the business domain. Public number of letters is around the same or increasing a little bit, but the volume is very, very large. And during festivals, it is like, unbelievably very large. So here we are. So we are looking at this box, which is rusted. So I was parking my car and there was this letterbox under the tree. And there's a lot of humidity under the tree. So the box was highly corroded. The door was dangling. People would post letters and you would see a lot of letters from the outside. And I was saying, can't we just change one product in the country, by having so much of means in IIT? So we took this as a cause. So that's what we're coming down to. You take as a cause that you need to solve this problem and you have all the wherewithal to do this. So designing a maintenance-free post box became the single line brief. So how does this line brief came is very important. We also thought of doing this project. Who do I have to go to? The India Post, and then I requested one of my students to take this as a project. Luckily, one student agreed. He said, I'd like to do this project. The Postmaster General in Bombay also was very, very happy, and to the everlasting credit, he gave this one-line brief. Maintenance-free letterbox. And you'll see how this is very important for the whole design journey. So then from our side, the trigger was very critical. I had a concern for the post. I had the empathy for the user. The letters are getting spoiled and dirty. There was a strong urge to make a difference. Like, we're all designers here, can't do one small product for the country. And then the conscience of the designer saying that usability and product features have to be very critical. So can't we change this? And generally designers have this dream that I need to do a product which will be seen all over the country. So it's part of that motive also. So then comes our next thing. So first the cause we've taken up. Now the context. Very, very challenging context. Look at the number of letters the people are sorting there. These letters are in the GPO, the General Post Office in Bombay, where they are sorting them for different regions. They are very skilled. They actually, throw these letters and they just fall in the right bins, and then you sort them and take them out. While this is happening, they have a high-tech sorting machine too, which is an automatic machine which finishes off all the sorting with infrared coded. So in this context, this area which is manual sorting for letters which can't be infrared coded, and there is this high-tech machine which they bought for crores of rupees which does the sorting for most of the other letters which are infrared coded. So we have a dichotomy. So there is a whole canvas from low-tech to very high-tech. And then we also thought about in the context, why do we need new products? What is the reason for new products, even in this case, for example? And you look at this timeline of this interesting pillar post box of UK. You started from cast iron post boxes. Later on, when it became more modern, you had sheet metal construction. So cast iron was the only material available during that age. Later on, large rolling presses came up. So sheet metal started getting manufactured more and more. So you have much lighter and different type of sheet metal post boxes. And then you can see stainless steel and plastic. So you have a lot of changes because of development, because of availability of manufacturing, new manufacturing techniques. And now there's a demand for more and more every season, and India Post doesn't have the letterboxes to supply. And I'm very proud to show you this slide where this was launched as part of the launch of our design, which happened in 2007. And they launched this commemorative stamps where they're showing their earlier boxes in the country. The green and blue one, what you're seeing, it's called the TV type post box. It's actually designed by a senior professor from IDC, Professor Atwankar. And all the cities started sporting these post boxes. And then again, they went back to those two boxes. And those are the ones which are the standard letterboxes now in the country. So what you learn from the context, you learn the history, you learn why things are changing, why you need new products, and you also look at the India Post. Huge buildings, large offices, large manpower, huge amount of volume of posts. So they have give us very interesting insights of the organization. It's an organization which is going to stay. It's an organization which has been established long back, but it's an organization which needs a lot of support to move forward. And then coming back to a box, what are the critical issues of who collects letters from these boxes? We need to understand that person who collects letters, because I'm working on a letterbox, and we found out that it is the lowest division clerk. He is the lowest division in the whole post office circle, and they go to collect the letters, and they are very, very ingenious in finding out ways when the boxes are bad, when the locks don't open, and we'll come down to those. Are you able to see why are the boxes different? Each country has a different box, a different requirement. Can you also check up the level of development in the country by the type of box they have? Could be. Yeah, look at each of them. Some of them are pedestal, some of them on the floor, some of them are on legs, some of them have a single pedestal, some of them have double pedestal. Look at the last one, Hungary, they have the cast iron legs. Look at the other countries, Indonesia, then Italy. Some of them are all uniform, one single monolith, and they could be old. Look at Nepal. Isn't it interesting? Concrete. Quite nice. Each of them is very good. Let them be old or new because of the issue of their requirements, their current conditions, and the type of vision the particular aspects have. Japan, that's not the right slide. I have the new box from Japan, maybe old, but they're old and new all put together. Spain, a round box still. This Spain and Europe, you saw most of them are similar to UK. Their boxes are very very similar, that round pillar post box. So understanding all this also gives us a lot of insights on what the country needs. So post box is for the country. It also reflects your development. It also reflects whatever materials you're using. It also reflects your identity. Because India Post is part of the ministry. So you have a bigger mandate. So we started with saying maintenance free post box, and now where have we reached? We reached at the level of country, saying that the identity of the country is at stake if you design a bad box. But it's important for us to understand the total gamut of the context, from the users to the level of the government, to the level of the offices, to the level of people collecting the letters. So all those become our context. Now look at the product specific insights, which I will show you one by one. If you have a flat top, water will stay there and you will be having rusting. So it's rusting, it leaks inside, and the tags are all rusted. Look at the other aspects of the typical letterbox. The life is not even more than 3 years. And when you paint some box like this again, you paint on top of the rust. So actually the rusting is happening inside and leakages happen. And even the installation processes are very, very tough. So your installation costs are very high, the painting costs and the maintenance is very, very costly. So that also has very important bearing. And water ingress, look at this very ingenious postman. He actually put a gunny bag inside so that the letters don't get wet, because there's water on the floor. Look at the other person where he's put a small hole over there so the water goes and stays there rather than stay in the box. So these are all the conditions of the post boxes. And look at the manufacturing defects. Can you see that edge which is open on the side? So how do you manufacture? What are the details which you use for manufacture? So manufacturing plays a very vital role. So from each of these insights, we're getting new aspects. Look at this design. They have a sheet on the top which is weak. So it bends. And that sheet, what's it's supposed to say? Anybody can guess? What's that sheet on the top which is bent is supposed to say? Direction to the post office. And then they got themselves so confused that their post boxes came so many locations that finally that has been eliminated. Now on the post box, we don't put direction of post box anymore. And look at this again. Because the bottom is getting wet, the postman put a lot of sticks and wood so that when the letter falls, it falls on those sticks so that the letters don't get wet. And look at the other problem. People putting cigarettes and stones inside. How do you prevent that? You can prevent all this. This is another big challenge. You have grass growing all around the post box. You have buildings coming up next to your post box. So what do you do in these cases? We are trying to make our box more and more better because we are studying all these aspects. Then look at this wall which has come next to the post box. So what should I do with the post box when there's a wall like that next to it? I need to replace it. I need to put in a new location in a corner which is better. But now this can't be done because in this case, the post box is actually embedded 3 feet into the soil. I'll show you that design problem, installation issues. Look at that cage. All that cage is inside the soil. It's also again a formula for rusting. You put some mild steel inside soil, humidity, and it can rust severely. Here you see people put a lot of posters on your boxes. How can you prevent that on your box? And what can you learn? There should be no projections because this electrical junction box is a projection which hurts people when they're walking on the street corners. So a lot of these interesting things you see from other products can teach you what to do with your product. Look at this slide. You will have to have special locking because we found out in our user study that the postman has to really hit the lock with a rock when it is rusted so that he can put the key and open. And study the user context in the toughest situations. This is a very, very important slide where we say that you have to study the user. Who is my primary user now? The primary user is the man collecting the letters, not the person who is posting, because he's has to be convenient to him. And the primary user's serious problem is during rain, how will he collect letters? And he has a very tough time balancing his umbrella. Why is it difficult to balance his umbrella? Because the post box is tall. If the post box was short, he would have gone in and he could have taken the thing. Okay, and then look at the keys. You've got 10 keys and he's fiddling with the keys to open. So we need to reduce the number of keys if possible. You can have a common key. So most of the check is coming from your study. And then he has to place the timeline, at what time he's clearing the letters and what is the next clearance tag. If he's cleared the letter at 3 o'clock, then he would again come at 3 next day. He has to say 3 next day, or he has to say 6 o'clock in the evening. So those clearance tags go into the post box. So we study those tags too. A number of times you can't even reach the post box. There are so many motorcycles parked around it. How do you solve this problem? Is it the problem of the post box or is it the problem of the people? It's both actually. How should your post box react so that this person will not park his motorcycle next to the post box? That is our concern. So I have to design my post box in such a way that a person has to think twice before he parks his motorcycle. And then the issues of problems. See how they put a cement concrete base around it so that the rusting is hidden and then further rust inside. So there's very humid inside the box, difficult to paint. So here we come up with a check. What is the check doing? It is giving us a clear direction, basically. It's also telling us what the product brief should be, what you should do with the product. And it also tells us, the design directions. Now let us see what the check says. So again, to the everlasting credit of Mr. Srivastav, who is the Postmaster General in GPO, he gave us this one-line brief saying that if you can make it maintenance free, it will be great. So what will be our first strong concern? Make it maintenance free, everything else is secondary. Then comes the long life and durability. Because it's a public product, it has to have long life. And then robust manufacturing. We saw all these problems. Your manufacturing should be so good. Your material have to be excellent. So robust manufacturing comes as an important concern. Then you look at user convenience. The postman, for example, should be able to put it in his bag very easily. The interaction with the box in range should be simple. And also, children should be able to post letters. It should not be so tall that children can't post letters. I'm very happy to tell you that as soon as we installed new post box on the campus, the parents actually gave letters to kids and said, why don't you post? We got new post box on the campus. So you can actually encourage use of post box or make it more convenient for kids to post. Then there should be a modular design because we found out that in festivals, a huge number of letters come. So during festivals, you can add an add-on box. So we say you should have a modular design, a small one and a large one. And then you should have a unique identity for India Post, least, but not the last, that you have to create a new strong identity for India Post and it should reflect a modern new image for the postal department. So the check and the product brief are very critical. When you make this list, it's very easy for you to work because you have a hierarchy of needs. So the first need is paramount and I will not compromise the need for any of the other aspects. The durability is very important. I won't compromise the durability from point of view of robust manufacturing. But robust manufacturing is important. I use the right material so that my durability also is there and my manufacturing also is robust. So similarly, the design and the identity. So let us now go to the most important aspect of a lecture, which is the creation, the conception, where we're trying to conceive multiple ideas. We group them into affinity clusters. We'll explain each of this term to you one by one. We create at least 3 concepts for every sort of project we have. 3 concepts are a must, and then we select the final design. So this sequence, for example, when you have multiple ideas, when you make affinity clusters, you have around 30 ideas in each cluster. Then when you make concepts, you have one assimilated concept, and then you design. So this is a very interesting journey. This needs specialized training. So now I've put up this slide specifically for you, and you can see that there are multiple ideas for each problem, but I'm only showing you 1 or 2 ideas for each problem. You can actually have 10 ideas for each problem, and that's what we encourage generally. But here, for paucity of time and slides, I'm showing you 1 idea for 1 problem. Now, for example, you have this rusty and damaged boxes in this slide. So what's happening over here? Because of mild steel, it is rusting. So the best option is to use plastics which don't rust. And plastics have round shapes. So that's idea number 1. Rounded shapes, no water ingress. So number 2 is use stainless steel. Stainless steel doesn't rust. And then you have flat boxes for stainless steel. Very simple, straightforward ideas. But they're only solving one issue about rusting of damaged boxes. Okay, now go to the next one. Rusty and non-functional locks. How do you look at rusty and non-functional locks? So here you're looking at, in this slide, you're seeing how you can think of interesting ways of locking by using special lock. So that one single key the postman can carry, and he can sort of go everywhere and use the same key rather than using a padlock or a lock. In this, we have the seepage of water is a serious problem, and the seepage of water happens because of stagnation of water on the tops, edges which are not closed. So you're coming up with designs which are rounded tops, which are like tapering houses, so you don't have any water seepage inside. Then you have seepage of water, again another idea where you make up for the dust in the box. So this idea is for the dust. Look at that post box which is fully muddy and no water is going in. So you need to put up in a pedestal. You're not doing something new. Your ideas are not your original, but you're imbibing some of the learnings from other places. So I know that if there's a lot of dust and muck, I need to have a pedestal for storing. The difficulty in gathering letters, what are you doing? You can have a tray inside and put it in your bag, or you can have letters stacked inside. This idea is coming from the check collection boxes. In the check collection boxes, have very narrow box. So when you put the check envelope inside, it just sits already stacked. This is not possible in our case, but all ideas are welcome when you're doing ideas. So this is inspired from check collection boxes. Oh, look at this wonderful idea for difficulty of collecting letters. They said make a door big, because current letterboxes are very small doors, so it's very difficult to take out the letters. If the door itself opens like big, then your collection is very, very easy. And then for the multiple keys, there was an idea that you can have a common key for a region with the same number and same lock. So one pin number, one key will open everywhere, or you can have a specialized lock, which we already discussed. Cumbersome and time consuming installation. You looked at those earlier boxes which had these large cages which went into the soil. So you have to dig the soil, you have to put concrete inside, and you have to assemble them. It was bad for rusting. So here you come up with better ideas, or you mount them on walls, or you put them on concrete platforms where you just bolt them to the platform. These are not new. These are all coming from lamp posts and the street lights. You see, all of them are bolted. So you can use concrete structure and bolt your post box, so that in case there's a problem, you can open it up and bolt it elsewhere. So there's an ease of moving the box. And then if there is a large volume post boxes during festivals, so there are 2 options here. You have an add-on box, or you make the box itself large. Look at the large box, square box. So you can have different ideas for different requirements. Again, we're looking at modular design. You can have a small box and a big box, as shown in this slide, where you have 2 designs. And today also we have 2 designs in our country. We have those small boxes which are in all the district headquarters and most of the villages. The importance of the box not being recognized. So what can you do for the motorcycle parking? You make your letterbox very prominent. So can you make your product look important? So you should have a presence. It should make it look important. So we have lot of ideas for this. Very interesting shapes. Remember the Nepal idea where they made it in concrete and large with a taper? Good idea. So you can have different ways of making your box very important. And then difficulty in bending and collecting letters. This is my favorite. In this design, the post box opens from the bottom. So what happens? You put your bag below and all the letters empty into the bag. Isn't that very interesting? So you can have a design where you don't need to take the letters and put them in your bag. You put your bag below and open the door and all of them come down. So that's a very good idea. Or put it on a pedestal so that you can collect the letters more easily. Poor maintenance makes the box looks dirty. So what do you do for maintenance? Have surfaces which are clean. Posters on the letterbox. How do you prevent this from happening? So actually you can ward this off by yourself suggesting advertising. So you put advertisement. So the person who is actually putting advertisement will protect his advertisement so that nobody else will put the letters. Or you make it difficult for people to stick by by making the surface such that you can peel off. Because every day the postman is going to collect letters. So he can maintain the box. He can actually peel it off. So you have to have a surface which is easy to peel off. So those are the two ideas which we came up with. And then putting garbage and stones and crackers for fun. There was a very interesting case where we studied that people, because it makes a good sound before Diwali and during, people put bombs inside so that the sound is very good. The posting slot was so convenient to put a bomb inside. So what does design do for us inside? So you make the posting slot such that you can't light the bomb and put it inside. So how do you narrow the entry so that stones and things can't go in, only the letters can go in. And the bottom idea is for areas where you are not able to sort of put a bomb inside because it's got to, travel inside and then falls inside. So it's very difficult to make the bomb travel inside. There's a flap inside, it can't go in. So you can think of ideas, ingress of. So can you imagine how, challenging it is when you generate ideas for all the problems you saw in the field? And is it possible to implement all this in the final design is a bigger challenge which we will discuss. We have a very interesting method where you actually bunch the ideas with an affinity. This can happen in any of your projects too. If you have a lot of ideas, you put them together and the ones you put together are because of affinity to each other. And this is a card sorting method where you use cards and do it. And it is based on the objective of the project. What is the objective of our project? The one line brief. Maintenance free. So maintenance free was objective. How do you achieve maintenance free? Generally, by having good manufacturing and good materials. So your objective will become, your clusters will be based on material properties and manufacturing properties. So that's what we decided in this case. In this case, the type of material and the method of manufacture was used as the basis for the grouping. And we also, found out that the prime criteria for grouping is in such a way that we see to that we satisfy all the aspects of the brief. So you put in a lot of things, interesting ideas to put together. So let us now see how the grouping happens. So all the ideas were there. We had some 100 ideas. What's the method of doing this sorting out? You have to make small cards of all the ideas. There's no other method, unfortunately. And you start allotting them. You make 3 groups, and you start allotting these ideas. So I'm just showing you one, small cluster. So this is called the sheet metal cluster. Why is it called the sheet metal cluster? It's got flat surfaces. It is amicable to designing by designing in sheet metal. So this was, one cluster which we generated. And in the sheet metal cluster, what are the advantages and disadvantages? This cluster, for example, gives you, the product is very strong. It is durable. It can be rust proof if you use. You can also make it elegant because of the large surfaces. It's easy to handle because it's lightweight and it can be fabricated in large numbers. What are the disadvantages? It has restricted shapes. It has to be always flat because you can't use car shapes because you can't have that type of tooling. It also has possibility of leaking through joints, which was the serious problem for our earlier boxes. So leakage of water could be a potential problem, and it will have welded joints which could be really problematic. And look at this cluster, which is the plastic molding cluster. You see all of them are rounded because it's molded. It's made out of plastic, so there's less rusting on the box, and it also has very interesting shapes. But then somehow I see some little difference. There's one in the center which doesn't really match the cluster very well, but it has been put in this cluster. There's no hard and fast rule. This has come into the cluster. Maybe the designer thought that we could put plastic folding and we can use this for this purpose. So that's the reason why he has got this into this cluster. So interestingly, the clusters are only giving you creative ideas to go and make concepts. So it's not really very hard and fast that why something should go in, why something should not go in. So here we have the plastic molding cluster. Advantages: it's elegant, it's rust proof, rounded shapes, multiple colors you can mold in. And the disadvantages are, not strong. People can, hit it with a rock or a stone and it can break, so vandalism. And color can fade in the sunlight. And in a product like a national level public product, you can't have things which are made of plastic. So you have to really, work out and check how to go about doing all these. So the next cluster is the combination cluster. You remember all these ideas? So the combination of plastic and metal. So here the top is made out of plastic and the bottom is made out of metal. So you have advantages of both. You have good smooth surface on the top for water to go out. You have all the body which is flat, which can store large letters. So best of both worlds. So this was a cluster which was a combination, and it used the advantages of both the metal because of the strong body. But still, if somebody hits on the top, it can break. So you need to work out on materials which are engineering plastics. So the top molded part will not break. You will have very good strong tops design, and the disadvantages can be reduced, and the cost is very high because you have both the plastic and the metal in coming up. And did you remember in the cluster we have ideas for one problem, right? Keys problem, visibility problem, user problem, and all the ideas are put together now. So if the put together ideas, so you need to combine them and make concepts, and you need to at least have 3 concepts. So we'll see how we sort of isolated the solutions and came up with there's a very rigid structure which we followed. So when you have a cluster of ideas, what do you do? So what we do is we generally take one champion idea. I'm just showing you 6 ideas there, and there's one champion on the right, and imbibe all the qualities of the other ideas in the champion. So it totally depends upon the designer's perceptions and how he's going about. For example, look at the idea which was there for making the product look important. That seesaw. How did you capture that idea into your final concept? By having large sloping roof. So it is an emotive contribution. It is not a direct contribution. So you have to understand that the ideas will not get into the concept, directly. They'll come through essence and through emotion. So look at the other idea of those flat surfaces. Look at that half round flat surface. The concept of that second idea was that as flat surface is easy to clean. So what have you done with your box? It's got flat sides. So it's very to clean. So it has less problem of rusting as well as corners being dented. So those are the ideas which are borrowed into the main concept. And look at those legs for the second row in the first. And then basic advantages of how this particular concept has a sloping roof, so water will not stay. It has a large flat body for easy to manufacture. It has large hood, helps in protecting the letters when you're dropping the letters inside. The manufacturing can be done by cutting sheet metal or stainless steel and folding them and welding only the corners. So a much better sort of design with you. Look at the next cluster and the representative. Inspired by all the other aspects, but it's very, very close to the one which is the champion, and there's an opening from the bottom in this design which is still being retained over here. Rounded shapes, so no rusting, completely sealed boxes, so letter collection is very convenient from the bottom. It can be manufactured using plastic molding process, and it's very rounded. So looks very new and innovative. At the same time, has this issue of vandalism which is not solved in this. And look at the concept C, which is very good for maintenance. If I put 100 marks for maintenance and not bother about vandalism, this will get selected. You have to give some weightages to all the aspects. So it's a very complex amalgamation of your brief that you can come up and select, where you have an amalgamation of a plastic top and a metal bottom, and that is the combination. You have a rounded top, inspired by Diwali bomb feature in the design, where you have a very nice chute inside, so that it's very difficult to put stones or or play with it. and you have a large door. So the whole door opens, all your letters are with you. So a lot of conveniences and advantages. And it is a combination of both A and B gives you the combination of advantages. At the same time, the disadvantages reduce because you're half metal and half plastic. So we have now three, concepts, and we have to choose one of them to go forward. And all the three concepts satisfy all the aspects of our brief. The first one, also satisfies all the points, but maybe it is not very high on maintenance, ease of maintenance, but it's very, very high on ease of fabrication, robust manufacturing, aesthetic, aspects. All those things are very good. See, all of them have good user features finally. Large doors or door opening from the bottom. So user convenience is equal in all of them. So you can really look at those checkpoints very carefully to see how we go about doing this. So these three concepts now we pitch against each other. Each concept has its own value, disadvantages and advantages. And we saw that the last concept was selected basically because it had the advantages of both the concept A and concept B, because it was using a metal box, it was using a plastic top to retain the rounded shapes, not let water come in, because when you cap with the plastic all around, there's a chance that there's no water leakage. It had all those issues of making it much more aesthetic, because you can have a top which is like more rounded and more contemporary in design and styling, while satisfying all the issues of maintenance. And you could use this wonderful initiative of getting the best engineering plastics. You heard about plastics which are commodity. We have these buckets and mugs in our house which can break if you kick them, or if you collapse them or hit it with a mallet. Whereas there are engineering plastics, like plastics used in racing bicycles, plastics used in cars. The bumpers of a car, for example, they take so much of impact. You also have seen plastics which are used for scooter parts, which are also pretty strong, and they're all specially blended plastics. So you have engineering plastics and specially blended plastics, which are very strong. So we thought if it's a small component, I can use this engineering plastics to make it really strong, because we are in the field there and vandalism was a big issue. Somebody comes and hits a stone, our plastic should not break. So here we are, that is the final selected concept. So that is the material considerations. Once you've done those the concepts, you have to detail them out. How will you manufacture this concept? What would be the shell? What would the top be? What will be the frame be? Like, look at those rough sketches of the designer where he just wrapped around his sheet and like got a front panel and fixed. This is the very first development of the concept. And then we because I was guiding the student, we always make small mock-up models. These are hardly 10 centimeter models. These are those very interesting creative models where the student then quickly made an aluminum sheet, bent it together, used a small PU foam top just to see how the box will look. And this is the very first form refinements. And then I told the student that one form refinement will not be enough. You need to check up, make multiple. So he did this. I said, my God, this looks pretty old. Look at this. The student was trying to marry the old rounded top with the new one. But then what it is looking like is looking like an old house. Today, if we make a new product, we need to make it very contemporary. People should feel that it is made out of new materials and new processes. So this is what happened. Then he went back, he made one more. He said, I'll take inspirations from, panels, TV cabinets, and, audio machines. What does transistors to do with postbox? Nothing. But you have those in your house. You have them all around you. So you have a perception of what a good style is, or what is the contemporary products which are in the market. For example, today you can't accept a Maruti 800, which was an old design. At that time we all liked it, but today the style has moved to much beyond rounded shapes and to new designs which are faceted, the Hondas and new cars which are coming in. So we have this perception in the people. So we need to look at products all around. So we looked at TVs and audio players, and he did this design, and we said this looks a little contemporary. So you could use this idea, and then he said, made this, because then what happened, you need to also make water ingress impossible. So if the water ingress was high, he had to make stoopings to the posting slot, otherwise water will get into the posting slot in the earlier design. So then you have a functional need coming into the form. There's a very large philosophy of form follows function, which is a very popular industrial design phrase, which also is very critical. So you always play between the aesthetics, the perception, and the form follows function. So this is the form follows function. It's a top which is sloping on all sides. There's no chance of water ingress, and also has very good hood for the posting slot. So you have all these, like options, very, very small models, and then you, select the one which is more contemporary, which was the marriage between the old and the new. So here you started making this CAD model where you have this one, like a box which is large rounded radiuses, and you have a sloping, roof which is more rounded to, show the earlier design. And then they said, no, it is not looking smart enough. Can I make it flat in the front? So you see the top has been made flat in the front. So this looks more contemporary. Then the back also has been further reduced. So it's a very fine formal refinements which designers do to make the product, look much, much more contemporary, much, much more appealing, and much, much more easy to manufacture. So here we are. So finally this, narrowed down to making it large radiuses and flat surfaces. See, the surface is flat on all sides. And this was finally, chosen to go ahead with. And then you remember, we are supposed to make two models, one the small one and the large one. And this we call the smart top because the product started looking smart and contemporary. So from here, then you go to what is called the first prototype. So how do you make the first prototype? Will you go to large manufacturing places, or will you go to small manufacturers who are craftsmen? You'll go to small manufacturers who can make one-off kind. So they're generally craftsmen, blacksmiths who do just one product. They'll keep hammering, and all these things, how they make utensils and all. So we went to one skilled manpower and we started, fabrication of this post box after we did all the detailing in the CAD modeling. So in this, you can see how the whole box has been detailed out, how you do the frame, how you do bending of the frame, how you put the plate in the bottom, how you put the base, how do you bolt them together, what type of door will fit. So all these are independent components, and all those are done through computer design, and you can get very, very accurate shapes and very accurate surfaces. And then you also have multiple parts for the top, which is made out of plastic. And this multiple parts are very important because you just can't make the whole shell in one go because there are different moving parts. There's a flap which lifts so the letter can go in. So all those are very, very critical aspects. So here comes our first prototype, made all out of hand. Look at those shining parts which are undulated. They look like handmade, right? Because in handmade, there are a lot of stresses in the plastic. And look at the top. The top also is hand done in our vacuum forming machine. The front panel is fabricated using small parts of plastic and joined together. And this is a very, very important technique students in design learn to make up a quick prototype or a mock-up model, we can say. This is a mix of a prototype and mock-up because the bottom section is using stainless steel, which is like a prototype, which is like strong, and whereas the top, which is supposed to be injection molded, is not a one piece. That is like a mock-up because it's got small parts which can break very easily. So this is a mix of both techniques. And then you use the same top on a larger box. So you have the design which is modular, the small and the large, and this modular design is the very essence of our check, where we said that we need to have two sizes. So from here we have those very important features of our design, which we said we want a prominent front panel. Look at the front panel. It is telling you when the box is going to be cleared and the information of the address where the post box is located. There's a nice overhang in the bottom. So you could collect the letters much, much more easily by sweeping them inside. And then you have this prototype which is now ready. So this prototype then we had to take to our postal department, and they were thrilled. All her postmaster generals from various regions in Maharashtra, Pune, Aurangabad, came, and we had a very, very interesting session, a GPO, the General Post Office in VT, and we had some fabulous inputs from all of them. They liked the design a lot. In fact, they covered it with a white cloth and they lifted it up and just to see the surprise, and they gave a very interesting insights. Some of the insights which they gave us was that they said that the top, for example, all looks like breakable and fragile. And when they opened the box, they said, why should I drag the letters into the bag? I would like to hang a bag inside. The suggestion came from them to hang a bag inside. So when the postman comes, he just grabs that bag and moves. So that we then implemented. We put 4 hooks so we could put the bag inside, a plastic bag which is reusable, so that the letters fall in the bag and then you can take the bag and go forward. So now look at this. Now where are we in the valley of death of a design? we are still in the prototype, which is the first valley. So by making a prototype, what have we done? It's a quasi-prototype. So I'm feeling that we're still in the middle somewhere there. We have still not climbed to a prototype which we can put in the field to get actual feedback. But we did get feedback. They said it was very fragile. See what we did. We moved the address details and tag into the door. The door is stainless steel and it's very strong. We moved that into the door and look at the box on the top. Now it just has a posting slot. That makes it very simple. So you can see how valuable the user insights are in the design process. So every stage you go to the user, you get phenomenal amount of inputs. So this was really, really very, very critical for the success of the design. So from here, we went ahead. We don't have any process in the middle, which is called product development, from an idea to the market. There are people who do mass production. There's nobody who can do small production. So we took up this responsibility of pilot production, and this is the one which has come out of the pilot production, that one design where you see, and I'll show you how we went about doing it. So we went ahead for pilot production to the best manufacturers. Then we ordered stainless steel from the market. You saw the stainless steel which we used for prototypes. They were like undulated. They look like hand beaten. But in a pilot production, I need to have very, very high quality surfaces. So we went to Jindal stainless steel, and they gave us one of their best grades of stainless steel, which is called Scotch Bright finish. So that the headlamps of the car, when they hit on that stainless steel, they don't reflect back. So, and then they also took us to their manufacturing unit, which is called the Jindal architecture, where we produced the components using CNC punching. What's the advantage of computer numerical punching of a sheet before you fold it?
Accurate corners and folds.
Accurate corners and folds, saving of material, nesting of parts. I don't lose any sheet. I just, punch all along and I take all the parts out. Look at the, sections which are coming at the end. Every small part I punch and use for some purpose. And I nest my components so that I use all the sheet very effectively, as well as the most important point is that it gives you very, very accurate parts and gives you very, very high quality. And now comes the laser cutting. In CNC, turret punch and cut the material. In laser, you cut using lasers. What is the difference between the two? Why do you need to use laser sometimes and the punch sometimes in a prototype? I'm doing a pilot production, right? I've got very less quantity. So how many punches will I have? If I have different diameters, if I want to cut a logo, I want to cut a postbox logo on stainless steel. So when you have prototypes, generally what you do, you use laser cutting because your volume is less. You can use laser to cut the material, and laser of course gives better edges. Laser also gives you very, very intricate shapes. And then what is this beautiful machine here? This is computer numerical control bending. Stainless steel material is a very, very tough material. Here we have all the inputs coming from our mechanical engineering professors, our professors from manufacturing. So we have all the good features we built in. Large envelopes can be posted. You have a posting rest. You can rest your hand to post the letters. And then you have these, design where you have no welding outside. Look at all the radiuses. Now, are you able to see the radius? The edge, you can see those shines which are because of the multiple 22 strokes of the round radius. And then you fold inside and weld inside. When you bend and you weld on it, it makes lot of stress undulation. So your sheet becomes very undulated. Then we have a tough composite top. Glass fiber reinforced plastic is very, very strong. And you can see they call the fiber reinforced plastics, FRP. You heard about FRP? They also using FRP, they make sculptures. Then we have this very interesting feature. So we put a sliding panel inside all the time. So he doesn't need to take it out. He quickly slides the time and he can go, and you can see the very prominent pin number and the location address. So this was a feature built into the door, and the door is very strong in stainless steel. And then we had this contemporary look because of the radius. It looked very contemporary, and because of the smart top, it had a look which was very prominent, so it was very easily visible from everywhere. And we had these large surfaces where we could advertise. And then we have all the features built into this. The door is also locking very tight, so you have no insects going inside. Then we have the foundation bolts put. See the reverse post box, and you can see the foundation bolts. So all the bolts are like from inside, so nobody can uproot the box by using spanners. And now when you're doing even 20, you need to consider transportation and packaging. So what did we do? We tweaked on our dimensions so that my top part, which is the box, can get into the door of the post box. So we pack the top, put it into the door. Then what happens? My volume reduces and my top is protected. Then what I do, I turn the base reverse and put it inside. Tremendous amount of advantage in transportation cost. Today, for example, if we have to send 20 boxes to Chennai, the cost of truck is 18,000 bucks. Look at number 1. That's how it reaches the customer, who is my post office in a remote location. Number 2, he has to take the base out from the top, keep the base outside. He has to take the top out, assemble the base to the body, assemble the top to the body, and your box is ready. Tremendous amount of advantage in transportation cost. So half the volume. What did we get by doing half the volume? Tell me. So it's a huge cost. We never realized that packaging is a big cost in design. So just see how we're getting into manufacturing, production, packaging in a very, very close way. And then the best thing happened to us when we got the order for 20 numbers and we said we want to launch all over the country. The principal secretary of Postal Department went and approached the minister to launch this box as part of their 150 years of India Post existence. So this is the interesting story of how we started with 20 boxes, and to our surprise, as soon as the program happened, now everybody knows about the box. So look at how design can flow. So everybody now knew that there's a new box. So they then said, we want at least 200 boxes to begin with. So then we took the challenge again. The challenge was to collaborate with large-scale manufacturers. We again approached Jindal. They produced the best stainless steel for us. They said, no problem, we'll give you low nickel stainless steel, which is cost-effective. Nickel is the one which gives shine in the stainless steel. So look at what happens. You can even change the metallurgy of the raw material if you are with the manufacturer. So designers have to reach that level if you have to have a successful product, that you change the metallurgical composition of your sheet which is produced so that you can have cost-effective products. So stainless steel sheet was produced at the Jindal factory. Then we had GE Plastics, which is the largest plastics company in the world. We had already had 20 boxes all over the country. So people started recognizing us. They came back and said, we will help you produce the engineering plastic. So look at that engineering plastic we produced. GE has a big plant in China. And I wanted red color because post office red is a very important color. So they did polymer processing in China, brought the granules to India, did the extrusion. Look at that extrusion machine in the bottom. Extruded the sheet in Ahmedabad and vacuum formed the sheet also in another company in Ahmedabad and helped us develop the top of the box. So now we are using engineering plastics, but you're using vacuum forming tools which are low cost. So from there, then we went to Godrej. The CEO of Locks division came to us and said, Professor Chakravarti, we'd like to be part of this project. Now look at this beauty. People are coming on their own and saying we want to be part of this project, and we could get the best locks, Godrej locks, onto the post box, which are non-rusting locks. Then again CNC manufacturing happened from Jindal Architecture. Then a very interesting problem we were facing. Our vacuum formed plastic parts are different parts. You need to adhesively bond them. And I was always very skeptical that adhesives will fall off. How many of you know that the aircraft wings are stuck with adhesives? So today there's so much technology in adhesives that you can actually have the adhesive stronger than the virgin material. So if I stick a plastic and a metal, my adhesive will not come off, but the plastic will break because metal is stronger. So we have adhesives of that quality. So we went to the best adhesive manufacturer called Huntsman, who make adhesives. They were in Hyderabad, and we produce the adhesives which will join these plastic parts so that the box is integral and nobody can come and whack away the top. And then we are supposed to bolt this box in the floor, right? So for bolting the box in the floor, we went to the best anchor bolts, Hilti, which produces these bolts which are drilled into the floor And then they got different types of bolts. They suggested a bolt which we should use is called chemical bolts. So it releases a chemical and locks in the floor. You have a concrete floor, you can lock this bolts inside and bolt your box on top of it. So you can take out the box whenever you want. So they got the best anchor bolts in this. So we had an all-round process. And what are these small models doing here? You can see my computer and see the model. Promotion, marketing and promotion is a very, very important component of design. Now everybody, we launched during the event, so we made 200 of these boxes. Your miniature should be better than the original, right? It can't be like a Khilona. It has to be very good. We went to the same manufacturer who coats bumpers for the grills of cars, and we got one of the best coatings of chrome on an ABS material, which is injection molded ABS, and we made this really good. Then we made a real brochure on this with all the advantages of the box: maintenance proof, very tough, easy to use, good place for advertising. All those things are on the box so that we sell internally in the within the post offices, as well as the people should know what the advantages are. It's a very important component of promotion. And then here we see how we went ahead with collaborative innovation of user-friendly design. We use very high-tech manufacturing. We have high-quality materials. Every material used is high quality and contemporary. Then we also made conveniences for everyone. The user, the people who are collecting the letters, as well as the people who are installing the post boxes, as well as people who are carrying the post boxes, people who are carrying to the locations. So we considered all our users, from the primary user to the secondary user to the tertiary user. We have a very, very elegant and modern look, and and it's also revenue generating, because if you put advertisements, your cost of the box can come back to you in 2 years. So this was a very interesting case study where we could do all the aspects very effectively in the design. And then we reached now the second valley of death. So I'll show you this intricate journey of how your product can fail, and once the product fails, how getting back onto track is extremely difficult, and what are the very important aspects we must consider so that we don't reach that stage of failure. So I will again like to take you back to our 7 concerns of innovation, especially showcasing this 7 concerns from point of view of aspects of the post box itself. So like I was mentioning to you, we're going to check up the 7 concerns of innovation by design. We checked that we stood for a cause, where we said we will look at the rusting post boxes, change the design so that it's convenient for the users. We can make it with better materials, and also make it more comfortable for installation, as well as sort of good for the postman to collect the letters, and as well as the end user to post the letters. So multiple levels of problems we identified, and we solved all that. So we also went and understood the context, who actually is the one who is collecting the letters, what are his problems, who are posting the letters, what are the scenarios around, what are the problems in installation of post boxes when there are muddy areas as well as concrete surfaces. We also looked at the other aspects of posts, where how they collect letters, how many letters are coming nowadays, are the letters completely personal or business letters coming in. So we understood the whole context, and then we went ahead and sort of checked the understanding of both the context and the cause, and found out that current key aspects, this post box, we have to very clearly understand that it should not rust. There is a lot of lack of maintenance and outdated manufacturing process. These are the key comprehensive points which came up. Then we went ahead and made up our brief, where we said it has to be maintenance free. Remember, this one line brief given by our Postmaster General, we said that it's maintenance free. So even when I fail in the product development stages, I cannot compromise on the points of the brief. So it has to be a maintenance free box. It has to use contemporary materials. If today's materials are like plastics and stainless steel and mild steel and powder coating, I would use those type of processes for my manufacturing. The product has to be very robust, because it's in the public domain. Robust means it has to be strong, it has to be installed. It has to be modular, because you need to have areas where there are people posting a number of letters, and some places there are less traffic. So you need to have a smaller and a larger box. At the same time, you have to do design so that you can amortize the cost, and we call it modular design, where you can use some parts common and some parts big. And then last but not the least, we said India Post is growing, they also want to be in the field, they're also becoming a very good organization. So why can't we think of creating a unique identity for India Post? This unique identity is very interesting. It also is an identity point of view of what we think from design, and when you have a new product, the identity becomes very important. I will show you while we go in the journey forward. So then we came up with these ideas, very clear how we amalgamated ideas and came up with concepts. And then how we chose the final sort of concept and took it to manufacturing. As we discussed the 7 C's, we came to the last C where we made a connection with the users. We manufactured 200 numbers and we sort of had this in the field, and we found out that the users, who were the large number of users, had this problem. So we went back to square one. So in this journey, went back in design process to see how we can redesign and take it forward. So let me again recap with you some of the details. That was the first prototype made at IDC, fabricated by plastics, and sheet metal fabrication was done by outside. Then where do we stand when the first prototype is done in our design process? We are in the very, very early stage of our design. We just reached prototyping. Even in prototyping, you have 2 types of prototypes where you mimic some materials, like for example, the top plastic was fabricated, the bottom was rigid. So that was the design which I showed you. And from prototyping, we went ahead and wanted to produce how many numbers? 20 numbers. So there's a mini pilot production. So as soon as we come from the prototype to production, you saw that the prototype had this very large fascia. The prototype was designed for what purpose, tell me? Was for large scale implementation. 2 lakh pieces, 2000 pieces. But when you get an order for 20, you will not have money for the tooling. Any plastic component needs injection molding tooling. So for injection molding tooling, you don't have the money. So you need to redesign the product so that you can make 20. So how did we redesign? We studied where the problems are. Then we said we will use this special composite hand molding process. So composites are very interesting. You come with resin and glass fiber, and I'll show you how we did that. So we went back to conceptual stage. We made a plaster mock-up. Then we studied what type of opening we should have. While doing all this, we were very focused on our process. They said the slope should be there, the water ingress should not be there, the top should be integral. So using all that now, the process is seen over there. We use a very simple composite fiber reinforced plastics where you put a resin, where you put a glass fiber, then you put a resin in a mold. And then when you take this out, it becomes like a rigid product. So I have one sample for you here. So this is made out of composites. So, this is all done by hand. You have a die, which is a negative cavity. So in the die, you do the resins and you develop the whole process. So this we did, and we, took this forward. The person who makes the fiber reinforced plastic top understands what type of shape I'm looking at. So from here, we made this top, and here you can see the top installed on one of the boxes, as well as the top which can go on both of them. So what have we changed? We just changed the very intricate top with a plastic front, plastic top, 3 parts into 1 part, which is done through fiber reinforced plastics. And when you have small volume manufacturing, you need this. See, we had to go back in our design because we need to produce 20, because pilot is very important to study what happens. Then, this composite top, interestingly, is much, much more stronger. It's very tough because it is fiber reinforced, and it did the purpose very well. And we produced our 20 numbers, with all the good features of easy posting slots, very large surfaces for advertising. It had a very critical and important aspect of a common key everywhere, and you had the time sliders. And you had this very interesting beak-shaped design, and nobody need to be told that go and post a letter there. So this is called user intuition. So when you have a slot like that, you would automatically put the letter over there. You don't need to specify that. And this was inspired by in analogies we call by the beak of a bird. And at the same time, it has got all the protection from the rain, the sun, and all those aspects have been considered. So here we went ahead, like we also marketed quite a bit. We collaborated with ad houses and they said, wow, this is excellent. Within 2 years, through ad revenues, the cost of the box is amortized. So you can always get it free after the second year. So it's a very good proposition for the government to install these boxes so that you can also get revenue after the second year. So rather than being use of money, you are able to get revenue from the post boxes by putting advertisements because that's a very prominent location. So then we sort of installed it in 20 locations. We also installed it opposite IIT Bombay main building. I was a chair professor for India Post. They were very happy to work with us very closely, and we produced these 20 numbers and the contract got over. Luckily, we started the Design Innovation Center at IDC, and there was some funding available thanks to the alumnus Mr. Sudhakar and Suresh Shenoy. That is one of the brothers, Suresh Shenoy, in the picture. So they took a lot of fancy for the post box. They said, this wonderful product. It's all about our vision of bringing in excellent manufacturing in the country. So they were very keen and they supported the project from the innovation studio. So from here we went ahead. Then to our surprise, as soon as we produced 20, we got an order for 200. So tell me now, once we have an order for 200, will my old top, which is made out of hand lay process, work for me? It will not. So I'll have to think of innovative ways of manufacturing the top again. Luckily, the stainless steel fabrication was anyway high quality CNC production. So it had all the components which you could produce through CNC manufacturing. So that was still there. So we went ahead back in our journey, went back to concept again. And then we tried a number of options. Remember, I was always telling you, we need to have at least 3 options before you decide what type of process to use. Can you see that white top? What do you think the material is there in that box which you see on the slide? The bottom is steel on the top. It was supposed to be plastic, but then I had to produce 200 numbers. So I said, can I try aluminum casting? So this is the aluminum casting top. We tried an aluminum casting too, because now I had to produce 200 numbers, and casting is a very good process to produce 200 numbers. Again, batch production, very convenient. We tried this and we found it very expensive. We also found it very heavy. So we didn't go ahead with this idea. Then we said, this is the sand casting process where you make a mold and then you pour molten aluminium and then you get your, one piece top. And then we said, let me try a next technique of low-cost tooling called vacuum thermoforming. So what is this process? You have a sheet of plastic, you heat it to the temperatures where it becomes like a cloth, and you wrap it around the mold by vacuum. So you have the surface and you suck the air out of the surface, it sticks to the surface of the die, and that is how the forming is done. In the cavity also you suck, it adheres to the cavity and you get this tray which is available. So we use the same technique to make the next level. So in this process, we had to go and get the raw material also. Luckily, we were happy that GE Plastics collaborated. So we got this granules. The plastic is made in the form of granules, and we made sheet out of those granules by extrusion. What is the extrusion process? You heat the granules and you extrude out of a thin slit and you get these slabs of plastic. So we extruded the sheet. Why do we need to extrude the sheet? Because nobody has this red color. We had to get the granules, we had to extrude the sheet on our own, and then we made these dies, the 3-part die, and finally you cut all the parts together and we joined it using the best adhesives from Huntsman manufacturer adhesives, who makes it really stronger than the virgin material. Today adhesives are very, very high tech. You have very, very good adhesives in the market which are as good as the original material. And then we have now the composite to thermoforming top, lightweight, formed out of 3 parts. This is one part, this is the front part, and this is the flap which goes in. And this again was very, very mass manufacturable to a level of 200 numbers. So we, using the cost, again, see the whole business when you come to large volumes like 200 numbers is cost. What type of tooling cost and what type of production cost. And because we are working with the government, it was very difficult for us to convince that please give me an upfront tooling cost and then give me the production cost. They can't do that. So they said, no, you said that the post box is going to cost 8,000 rupees. We can't give you more than that. So we have to work out innovative ways of pilot production of how we went ahead with making the top. You can see one of the boxes sporting the top. So here we have the tops ready. Then we made all the drawings ready. You can see how engineering drawings are made with all the details. And this is the assembly drawing. This is the drawing of the base. You see the small indentations to make the stainless steel very strong, and how the whole situation was taken forward, and then how the fabrication was, drawing was made. And remember, I was talking about embossing on the post box to make it very strong. So we reduced the cost by 3,000 rupees by reducing the thickness of the stainless steel. So what we did was we used this work hardening property by doing constant bending. The stainless steel edge, the corner which was the most important, became very strong, and we reduced the thickness of the stainless steel sheet from 1.6 millimeters to 1.2 millimeters and saved around 3 kilos of stainless steel. We have these embossings which makes the surface very strong. So we use the embossing, we use the bending and made the product very, very strong. So from these then we went ahead and we went for pilot production. See how through laser you can cut very intricate shapes for your profiles. And this is where you can get all the rounds, the rectangular cuts, and you can take it for fabrication where you get flat sheets. You take the flat sheets to this machine to do the bending. What is very interesting about CNC bending operation is that this bending operation is very, very intricate and very accurate. Stainless steel has a property of spring back. If you bend 90 degrees, finally you will land up with some 87 or 86. So this machine has the capability, a computer, to calculate the material properties of stainless steel. You can feed in the grades, 304, and it will bend exactly 90 degrees. It has that capability of calculating and bending. And I also told you that to get this radius, we had 22 strokes. So it did the 22 strokes on the machine to get this radius. So by 22 strokes, what do I get? I get more strength, more rigidity. And where do I need strength and rigidity? On the corners. Those are the areas where the damages can occur. That also I found it from the factory. That's why factory visit and materials understanding is very, very important. So it was fabricated. So then we had this interesting process of getting the raw material manufactured. So we also got this scotch bright finish. You can see this dull finish manufactured in Jindal stainless steel. Then we got the plastic, as I showed you, manufactured by GE Plastics. We got it specially tailor-made manufacturing for us. Then we made this rust-proof locks from Godrej, because when we went during our survey, we found out the locks were rusting. Then we went for CNC manufacturing, very, very high quality manufacturing with again Jindal architecture. Then, as I told you earlier, we got the best adhesives so that there's no chance that these things will open up in the field, because they have to be really, really strong. And then when you bolt it to the floor, there's a lot of technology in bolting where you use anchor bolts for bolting the box to the floor. And that also is a very large technology of expansion anchor bolts which are bolted to the floor. So we went to the best companies to get this thing done. And then we implemented the 200 number. It was a great experience to see the whole factory full of these boxes in Jindal. I was in the factory. We had quality control from IDC. So we had our staff flying to Delhi, checking out whether the quality is right, all the systems are working properly. And finally we dispatched 200 numbers to different parts of the country. So it was installed all over the country, from Jammu and Kashmir to Kanyakumari to Guwahati, and we waited for the results. So this first dispatch, India Post is a government organization, it's a ministry, so very, very sensitive to feedback. So they said that first we will install 1010 in all these locations, we'll get feedback from them, and after feedback we'll give you the larger order. We will then put a tender for a larger order and it will go into the market. Very logical. We were also pretty happy because the first 20 gave us very good results. The first 20 were put up in 5 different locations: Mumbai, Delhi, Patna and Chennai. But what went wrong with us was, from our design process, was there was no rural area. It was all put up in cities. So what type of feedback did I get? Excellent, very good. You saw all those newspaper clippings? Like past imperfect, future perfect, whatever, all those great feedback we got. But then what happened when we made 200 numbers? When we put 200 numbers in the field, they went to all the remote locations. Because what happens when you give individual post offices, they only put up these boxes wherever there's a need and wherever there's a requirement, there's a waiting list. So as soon as the 10 new boxes went, and the waiting list could be in the district areas, in the rural areas, and everywhere. And then we got the right feedback. Most of the population is in the rural areas and district headquarters. And from people-centered point of view, the design identification was, not thought of. And then we got a user feedback where large number of users could not recognize the box. So after doing this whole story, you realize what type of shock we can come to if we don't keep the larger user base in our mind. We got a feedback of around 60 to 70% of the post officers said people are not able to identify our post box. There was a double-edged sword here. When you send one box somewhere to a remote area, there's hardly any identification because all the other boxes are round. And there's no advertising, there is no information processing, there was no paper articles like the cities. So there we, fell back on. And then the long-standing image. See, this is again very important. The post boxes are classic product which stayed for 40 to 50 years in the field. So there's an ingrained image of the box in the minds of the people. And the paint companies sell paint by calling post office red. You heard about it? Post office red. It's so important. And the red color was very critical. Stainless steel confused the city. A lot of people came from rural areas to cities. Even in suburban areas, some of the people got confused saying that it could be a dustbin because dustbins were using stainless steel very heavily. The city environment. In the city environment, there were dustbins and there were post box in stainless steel. So they would confuse it with dustbins, large bins in metros and all. So it's a very, very shocking revelation for us, but we took it in our stride. We said, this is the mandate of the people and we need to, be humble and understand people's needs more closely before we go ahead with our design journey. So then we went to Ministry of Posts again. They got a feedback. They had a board meeting in which they said, oh no, we don't want to change our round look. We want it round. Let Professor Chakravarti design better manufacturing using round shape. Why should we change the shape to rectangular or square? So, we fell flat on our face. Then they said redesign the same modular and good manufacturing, CNC and all using round shape. And all other features were appreciated. Everything else is good. It's excellent, new manufacturing because today materials are new. Use stainless steel, no problem. But retain a round shape. So they sent a letter to me, now design a round one. So where are we back now? From pilot production, we fell back to mock-up. This is the third time we're moving there. So that's a big challenge. So now look at this. Make a round shape, use the same high-tech rolling machines, get a flat front, and we went with this model. We made a small model. This time we were careful. We made a small scale model, the size of 15 centimeter scale, and we took this model to India Post directly to the ministry, to Delhi. And they said, no, we told you round, there's a flat front. I said, how does it matter? Flat front is convenient for people to take out letters, right? If you open a flat door, it's convenient to take out letters, so we put the flat front. They said, no. Now they become very rigid. We want round as round. Now we are facing the music. We said, okay, we'll make a round design, and we redesigned using the same materials, better manufacturing, and went back. I'm showing you how we went ahead making the CAD models, the whole structure, the different parts in that, the landings, the door in round shape, the top posting slot in an interesting shape to match the overall configuration of the post box. You can see how we made the base also now with a rigid structure inside with a round, round base. We could have had a square base, but we didn't want to take any chances. And then we suddenly got a call again from Delhi that we have got this Commonwealth Games happening and there's a large exhibition and we need to put up this new round box in the exhibition. So from CAD modeling, we had to rush to prototyping. They wanted a single piece. We got all the stuff out. We went to local craftsmen and look at that sheet that looks rusted, but when it's treated, it becomes shining. So they rolled. That's a rolling machine on which you roll your sheet. Then you do all the fabrication by welding. All the surfaces are all weld together. Then you do the painting. We did the painting processes, painted them after treatment so that there's no rusting inside. And then we did the top, the round top. We've learned our lesson. So like we did the hinges, the doors, the details, pretty tough. We had the whole team to work on this. We had experts, we had a team of 10 people working on this at that time. And then we put up one near our main building just for photography. And like we sent this prototype to Delhi. And they put up in the exhibition, the secretaries were very happy, the directors were very happy in India Post. I said, wow, this is the in thing. And then interesting thing happens, the secretary also retired. So we were again in a fix. We waited for a long time, 6 months, we waited, no result came up. And then a new secretary came up who knew our work earlier. So he contacted us and said, what's happening to your post box, he asked me. I said, my God, this is interesting, let me get back to my old design. So I leapfrogged to my old design. I said, I have the box, there's a problem only with the red color. I just painted red and it's going to work for you. And I'm going to change the top to a rounded top, marry the old and the new, and it will be work. We put the old and the new during Tech Fest exhibition in IIT. And then we called this man from Delhi. He came and inaugurated the, sort of exhibition. So here we have again the square box, painted red, because there's an advantage of manufacturing in square. You fold very easily rather than rolling. And then, we sort of, did the tooling now. Now what happened is, by that time we realized that out of the 200 boxes, when the plastic top went, people thought that they could recycle the plastic. So people were actually stealing the plastic tops. Giloy is a difficult material to recycle. They were not able to sell it, but nevertheless, they would put a bamboo rod inside and whack it out and go and sell it. Plastic top was not going to work. So we went back. We said, we'll make a metal top, bolt it to the to the structure so that nobody can, take it away. So this is the tooling. Now my team from IDC started working. We made a die, this metal die. We did deep drawing. Deep drawing is a process where you have a sheet metal and you have a large press which presses the sheet metal to get the shapes. All your car bodies are deep drawn. The rounded shapes of your car bodies, the large tooling and dies, but this is a very small one for us. So we did these metal tops. So this is the top. And this top, what is interesting in this top is it's got a feel of the old and the new. The round is from the earlier design and the square is from the new design. And when it's in red color, there was very good recognizing. People had no doubt that it was a post box. So which is the best part in design? So we went ahead in the process. We fabricated the top. We did the deep drawing. We got the sheet metal part out and we painted it. And we were so excited about the whole journey that we published a book on the design. Read through to see the whole story of how the design process went. So I think it's a good example of crafting where you have engineering strengths coming in, manufacturing strengths coming in, and a lot of innovation from point of view of contemporary materials from plastics to metal to stainless steel. So finally, what we did was because the stainless steel is not using the shining property, right? And that is the costliest part of the stainless steel, which is called nickel. So we now have a material which is low nickel stainless steel. So in the no nickel, we have a low nickel stainless steel, and on the low nickel stainless steel, we are doing powder coating. So there's one more protection. So now that is going to work very well in this aspect. So I thought I'll just show you this total journey because this reached a stage of pilot production, going back to original concepts, and the to and fro happened nearly 3 times, and still we are waiting for our sort of approval to go into mass scale production.